Hello all, welcome to Tech Visas. In this video, we will discuss about strong versus eventual consistency. If you have seen my previous video on cap theorem, where I explain in detail that whenever we are designing a system, we might need to do a trade-off between availability and consistency. So, similar concepts we have to also apply to the consistency. Whether we want to have a system which is very strong, consistent, or maybe we can live with the eventual consistency. So to understand these concepts, let's take example of a single node system. So where we have a single application and database at just at a same node, right? And it is storing some value of variable x or maybe some other value as well, but now clients, maybe individuals or applications can send their read request to the system. Now, whenever a client send read request, they can get the value back as 10, right? But in case there's a change in value, and now suppose the value of x becomes 20. So in this case, even if there are some more read request, they will get the new value because it's only one node. So there is no issue of that in the client getting the old data, right? Because all everything is synced up at only one node. So if we have this kind of a system where we have just one node, then the system is highly consistent, or we can say it is following concept of the strong consistency. But there's a problem here. So the problem is basically it is a single point of failure. If the application, because of any reason, maybe a network failure or something else, goes down, then it's like whole app is gone down. Very, very bad experience for the customers, right? So to avoid that, we normally use the multi-node system, which is very distributed. And for example, here, right, we have three nodes. So we have three nodes which is having the like same kind of infrastructure and also the values of x. So at this moment, all three nodes are synced up. There is no data which is not synced up, but now users are sending their read requests, right? So now they will get their data back properly because all nodes are having proper data in sync up mode, right? But what happens, suppose there is a update happened at node 1. Now the value of x becomes 20. So suppose there are some more read requests landing at node 2 and node 3. But the problem is here that node 2 and node 3 doesn't know that there's a change happen in node 1 for this variable. So they will send back the old values. So it means that clients will get the old value which is not applicable at the moment. So how to avoid this situation, right? So for that, node 1 must send some updates to other nodes, right? Node 2 and node 3, so that they can also be made aware that value of x is not 20 and is no more 10. So, but whenever we are sending these updates to other nodes, in between we can't allow users to read, right? Because if we are focusing on highly consistent data, right? If we are focusing on the strong consistency, we have to make sure that client gets the correct data and current data, right? So for that we have to block the reads, right? So it means that system is now less available because whatever request which are reaching to the node 2 and node 3, in between the update is going on, so they won't be able to read that data for some time, right? So it means that now system is very having this strong consistency but less availability, right? So Now, suppose now we have to understand the various use cases when we need the strong consistency, or when we can live with the eventual consistency. So, for example, if we are having a application which is used for trading, right? And similar setup is there. You have three node for this application, and for example, this application is sending the current rate of stock prices. So at the moment, all the nodes having the same price of stock, right? So there is no issue. Clients are sending their request, they are getting back the response, fair enough. But now, what happens in case the stock price at node 1 updates to 20? So now node 2 and node 3 are not aware that stock price has changed. And in between, if there are some more read requests coming from the clients at node 2 and node 3, so because stock price should be consistent, right? Clients should get the same stock price. What is the current stock price, not any previous stock price, right? So we have to make sure that this application is strongly consistent because of the use case, right? Because we cannot say that, okay, take the previous value of stock. We have to give the current value and the correct value of the stock price. So now node 1 has to send update to node 2 and node 3. And after update, and now in between update is going on, we have to block the reads, right? So node 2 and node 3 cannot serve any more request for that time. So to make sure that our application is strongly consistent. So in this scenario, whenever we are having the trading application, we have to focus on the strong consistency. Now let us understand. Suppose on like in which case, in which use cases we can use the eventual consistency. So for example, in YouTube, right? In YouTube, for every video you see there are some views count, right? Maybe some view count changing, and sometimes you can also see that they're static, right? So now, for example, we have three nodes which are storing the views of any particular video, right? So at the moment, all the nodes having the same value of views, but and the reads are happening and from the client, and they are able to uh, video view request they are sending, and they are getting the view count of for those videos. But if there are some changes for some video at node 1 and count is changed to 20, so now do we need to block the read request from other nodes until those are updated? No, right? Because the count of views may vary, right? Because it just gives an idea what is the current count of views. We need not to be very accurate, because if we are going to be very accurate, we have to basically block the read request, and that will make a system very, less available. Because for social media applications, we have to make sure that they should be highly available. And also, even if other nodes are sending the stale value of the video views, it's not going to matter much because people are just trying to see the count for their general idea, not for any particular like suppose any other use case, right? So for this particular YouTube video views count use case, we need not to block the read, and reads can happen in parallel. Maybe if some requests are landing at node 2 and node 3 before updates are done, but still they will get the old data, so that will give some idea. But yes, we have to make sure that node 2 and node 3 come into sync. But there's no urgency. We will slowly, steadily update them. So that's why we say that system is eventually consistent. Maybe at the moment, data is only available, which is like current is node 1, but node 1 will make sure that, okay, it's also updated in the other nodes as well. So eventually, it will make sure that data becomes consistent across all nodes, but in between will not stop any read request, so that a system is highly available. So now we have to basically understand and see each use case, case by case basis, whether we can live with the eventual consistency, or we need the strong consistency, right? So that have to use in very pragmatic way. So yeah, that's it for this video. Thank you very much for watching. See you next time. Please leave comments or questions if any, and please subscribe my videos as well. Thank you very much.